Welcome back to the channel. Today we're going to be diving into one of the coolest intersections of math and history, being Egyptian geometry. So the Egyptians had already created areas, volumes, and even building some of the most precise structures in human history long before Euclid. And today we're going to explore how they approximate the area of a circle, how they compute the volume of a truncated pyramid, and we'll finish with some mathematical speculations about the Great Pyramid of Giza. So our first stop is the Rhind Papyrus, which was written around 1650 BCE, which contains dozens of problems, including one that shows how Egyptians approximate the area of a circle. So ancient Egyptians did not have pi, so instead they used a geometric shortcut. They took the diameter of the circle, subtracted 1/9 of it, and then squared the result. So in modern notation, it looked like the area was equal to the diameter minus the diameter divided by 9, all to the power of 2. So now, in order to simplify this, we can see that this will just turn into 8d over 9 all to the power of 2, which when you put in the square becomes 64 over 81d squared. Now, this would correspond to pi being approximately 256 over 81, which is approximately 3.16. which is impressively close to the real value of pi being 3.14159 and continuing. So an example that we could do is by setting our d value being equal to 9. So when we set our d value equal to 9, we'll see that this will become our area is equal to 9 minus 9 over 9, which is just going to be 1 to the power of 2. So this is going to just become 8 squared, or 64. Now comparing this with the modern formula, which we know is A, our area of a circle, is pi r squared, we're able to set this equal to pi multiplied by 4.5, all to that to the power of 2. Which gives you approximately 63.6, meaning that their answer was 64 and our modern answer is 63.6, which is less than a 1% error, which isn't bad for a civilization without calculators. Next, we're going to be looking at the volume of a truncated pyramid. So this is also known as a frustum, and appears in the Moscow Mathematical Papyrus, being problem number 14. And the Egyptians had a formula that matches the modern one exactly. So for this problem, we're going to choose purple, and we're going to have our lower base being A, and it's going to be the length of it. Now we're going to have B being our upper base length. And then finally, our h is going to be equal to our height. So now the volume is going to become, I'll do this in blue, our volume is equal to h over 3 and then a squared plus ab plus b squared, which is the same formula that we use today. So in our example, which we'll do on the right side, we're going to say that we're going to set our a value being equal to 6, our b value being equal to 4, and our h equal to 10. So now all we have to do is plug it into the formula. So our volume here is going to be equal to our h over 3, which is 10 over 3, multiplied by our a squared, which is 6 squared, plus 6 times 4 plus 4 squared, which will give us an answer of 10 over 3 multiplied by 36 plus 24 plus 16. And since 10 over 3 isn't a perfect answer, we're going to get an approximate, but it's going to be equal to 10 over 3 multiplied by 76, which is approximately 253.33. Now we're going to talk about the Great Pyramid. It is a structure that is so precise that it has inspired centuries of mathematical speculations. For example, the first thing that we're going to go over is the pi ratio. And the pi ratio is that the researchers have pointed out that the perimeter of the base of the pyramid divided by the height of the pyramid is approximately 2 pi. And we can show this by using the pyramid's original dimensions. So if we draw a dotted line, and we'll use purple again, the original base side, which we'll just call B, is equal to 230.4 meters, while the height, which we'll call H, is equal to 146.6 meters. So the perimeter is going to be equal to 4 multiplied by 230.4, which gives us 921.6. Now computing this, we get 921.6 divided by 146.6, which is approximately 6.29. This is while 2 pi is approximately 6.283. So the match is extremely close. But the question is did the Egyptians intentionally encode pi? Which is something that we still don't know. Finally, we have the golden ratio, which is another speculation that the pyramid's slant height and half base form a golden ratio. So we have phi, which is approximately equal to 1.618. But if we have the measurements being our slant height of the pyramid, and we divide that by half of the base, this will actually give us an approximation of 1.618 again. So it is again close, but the debate is whether it was intentional or accidental. So today we saw how the Egyptians estimate the area of a circle, compute the volume of a truncated pyramid, and built structures so precise that people still debate their mathematical intentions. If you enjoyed this blend of math and ancient history, hit like, subscribe, and tell me in the comments which ancient civilization you want to explore next.